Then we see the idea of how to parameterize the system and the difficulty that is coming out of the parameterizing the system. And there are two cases, the same way that we did it before, minimum phase system and non-minimum phase system. We are going to do the minimum phase system, the non-minimum phase system.
No, and be correct. There is a smart.
Then we see the general design issues that are going to come with the track that we go there through the estimation.
When we estimate the model,
basically what you have seen
this model there are
our
two types.
calculations
There is the
before,
B,
when you go from
there is the A.
accepting all
So
the
what we
zeros or
estimate
rejecting
is
all
also
the
B
zeros,
and
you
A.
find out that the
So what we get
calculation
is
more complex.
B hat
More equations
and A hat.
equations
Huh?
are, yes.
But
Not
when we
necessarily
implement it in the
everyone
controller, we
that
put the
is,
A over B
full
hat. Yeah,
consolidation.
totally normal.
But we have seen that if we accept and we say that there is
Your question
a
is?
full acceptance of all the zeros, then we may end up by
replacing here
so there are some positive and weaknesses.
It's a polynomial. My control, your controller is telling you, your control method is telling you
How we can avoid this by the system. The second thing, we have seen that
That's right.
the previous time we were working, we are identifying the system,
but it's your estimate.
and then we identify B and
It's
A
not another
based
transfer
on the
function.
value
And
of B
A over B, it's not one term,
and
it's
then
two
we are
terms.
repeating this at every step.
So you when you put your
And then we
algorithm
are
of
assuming
estimation,
that the
my
signals
algorithm of
that we are
estimation
getting,
will
the
put A.
indications are rich enough in terms of
This is my least square method.
that they will allow us to identify these
And
values.
this least square method will
But in
generate
real
for
life,
me
it
an
will
estimate of
be
A,
not the case.
an estimate
So
of B.
in real life, the way
And then I will
we
use
go
the
around it, we inject artificial noise in the input, and we see
To make them.
the system and we can
our
add more.
It's algorithm. This is your controller. All this is your
But for
controller.
mechanical system, for example, if I have a
This is-
compressor and I add noise at the level of the input, the compressor will filter all this
This
noise.
is your
You will not see anything of it at the level of the output. So maybe you will add the noise, but the noise is not enough to make sure that you are getting enough.
So everybody is okay with this?
Consistency.
With the inverse model?
So this is why we are
Using
talking
it to
about
close the gap
numerical
between Y and
conversions
Y.
and air
And
condition
then the
systems
feedback is
based
taking
on
care
the
of
identification
any
of B and A.
errors in the estimation.
So basically what we are saying that since the
And we
this,
understood yesterday that
identification, this
I design
can be time
my
consuming, can
controller
be a little bit sensitive to B and A.
by
Let's go and
inversing
find
the dynamic.
value
When I
of
say my controllers, I design R
directly
and S
from-
and T. By looking to
From the identification and
the inverse of the zeros that are bad, then S
So what's the
over R
idea?
will
The
be
idea is
stable.
that we reparameterize the system. So the system, we take it as is and then we reformulate it again. in order
So there are
to,
other things that we need to add in order to help us with the way we are going to
appear
design.
in the difference.
So last time we put some inequality,
So
this
it becomes
response is
part of
equal,
our-
but
and
during
then
the
we
work,
do the estimation.
we are estimating, we are saying, what if we are at the limit? What if we are at the
So
limit?
how
For
to do
example,
this?
We said that
Um,
degree of S is less or equal to n minus 1.
So this is basically what
degree
we are
of
trying
R
to do.
should be bigger than n
We
minus
take
1.
the input,
So this means that we
take,
put
which
ourselves
is
at
the
the limit
control
at the
signal,
boundary
we take
n minus 1. We
output
fix
of the
the
system
degree.
here. We
So
go through
the way to fix the
estimation
degree,
and then from the
we are going
estimation
to put it
algorithm,
based
we
on
go directly
these
with the parameters.
conditions, and we call these the
We don't have to
compatibility
find
conditions.
values.
So the compatibility conditions,
And if
we
I
are
put
going
the
to
noise
select
at the level of
the
input here,
reference
the problem
model,
of
the
persistence
same degree as A.
exactly
we are going to select the degree of Bm the same degree as B, and then degree of A0, of course, it will be equal. It will no longer be inequality. Everything will be at the limit.
So how we do this?
So we call this the
first of all, what we
compatibility condition.
what
So
we
how
know
the
is that
algorithm
the
works?
process model
The
is
algorithm
given
works
by A
as
times Y is equal to B.
if you want a function where you submit the value of A and
What
B.
is also given for
So
us
this is the data that you are going to put at the input level. You submit the value of A and B.
the reference
From
point
these
is
conditions
the
that we
reference
verify,
point
we check
is
if
given
P
by
and
the
Bm are the same
A
degree
multiplied by Y.
as A and B, degree of A0, if it's compatible with this equation.
And from the
Then we
calculation
separate
that we did,
Bm and B
we
minus
were
times
able
Bm
to
prime.
put
And then we are
the
able to
structure
apply
of the
directly to
structure
find
of
out
the controller has
controller.
three
So
parameters that are
we
known.
decompose B
R,
and B
T,
plus
and
times
S.
B minus. We generate a solution for L prime and S according to
So
this
the idea
equation.
is now work around this. in
We
order to make
generate
sure
the
that
solution for
controller
T as
is
A0
in
times B
relation
prime, like what you
between
did
Y
yesterday.
and B.
And once
So
all
we
of
know the
this is
characteristic
defined,
equation, we know
then I
that
can
the
find my control
characteristic
input
equation
Q.
is
So the
equal to
output of this
A
function would be
AR prime
U.
times B minus
Right? Which is
B
T
minus
over R
times S
times U reference minus S over R times Y. I take this U and I apply it to the system. I will get Y. I will get an estimate of A and B. I will call this function again.
So what we do,
So this is how it works.
we multiply, we take
It will stop.
A0 times AM multiplied by Y of t.
It's your
And then we are
control. You are
able to
continuously under
write
control.
this as equal
Unless
to
you
the
stop
same
the
thing
control.
as AR prime Y of t plus B minus S times Y of t. So basically I take this.
We don't stop.
That we have
It's
and
done
then multiply by
based
Y
on the
of t
clock.
from both sides.
So they have a clock of this.
Right?
And
Then,
they have a clock
since we
that will
have
govern the
the
estimation.
equation here, we
I
are
talked about
able
this
to
one time.
know that
Okay, I
A
told you that
multiplied
most of
by
the time we use them the same
Y of
clock,
t
but
is
in
equal to
certain
B of
systems
t.
we don't identify all the time.
We just replace
So we
the
have
B.
the control every
And we
0.1
continue.
second, but the other one will be after.
So at the end of the day, what we are going to get is a relationship.
But in the
that
transient,
will give me A0 multiplied
your
by
transient
AM multiplied
period,
by
you
Y
need to
of t
be able to
is just equal to B minus 1 times R multiplied
to estimate
by U
your
of t
values.
plus
You
S
cannot wait
multiplied
5
by
minutes
Y.
with an estimate that is wrong, for example.
So this equation
You
here,
remember,
the
this is the
left-hand
square
side
method that we are going to apply
because
here.
it's coming from
This
our
square method,
example, coming from
recursive
this.
square method, because we are going
The right hand side
all the
here
time, has
R
to
and
start
S
with
are
initial
known,
values.
and
The
B
initial
minus
values
is
are
also
P0 or P,
because we said
and
that
the
we
initial
don't
value
know
of
this.
your
And we
parameter
don't want
theta.
to know this. Everybody
So
is
if
okay
you
with
are going to start
So
with
this
any
is where
initial value of
the
parameter
problem
theta,
starts.
then you need
Difficulty
to
starts. Difficulty starts from
probably
the fact
make a
that
condition, unless
we
the error
have
is less than
unknowns
something,
in B,
you
unknowns
should
in
keep
R,
always
and
at the
unknowns
same
in
frequency
S.
as the control.
And then if you multiply
Once the error is
B
within
minus
reasonable
R
limit,
is a polynomial.
then you can relax.
If you multiply it by the polynomial R or
Is
if
it clear
you
what I said?
multiply it by the polynomial S,
It makes
then
sense?
you are going to have a cross multiplication of parameters of B minus with the parameter of R or B minus with the parameter of S.
So now we are going to start the fun part.
So when you have this cross multiplication between terms, the
So suppose
parameters
that you
are
have
no
the
longer
system like
linear.
So this is 1 over S.
Remember when we did the least square
This is
method,
your plan.
one of our assumption was
But
linear
in continuous,
parameters.
and we said we are going to work
So
here.
linear in parameters means that I'm able to write my system as a regression
So
function.
to work on
by
this
t
grid,
multiplied by theta.
I need to
So it is
transform the
linear.
system.
But
And
right
I
now
need to
my
transform the system based on a
parameter theta
sampling
is no longer
frequency.
linear.
Sampling period.
It's not linear, so therefore we have to see how we are going to do.
Now, if you do the simplification of
And then
this,
example.
or sorry, the
For
transformation of
example,
the
if I
system,
take B as B0
discrete,
multiplied
using,
by
for example, C
Q plus
the
B1,
function from
and I multiply it by
using
R, and
0.5
I will
seconds
assume that R is the first
as
of the system. U
your
plus
sampling
R0.
period, then you are going to end up with a system like this.
Then what we are
This is
going
B,
to have is B0
and this
Q
is
squared
A.
plus B0 R0 Q plus
Everybody is okay with
B1
this?
Q
Is it hard
plus
to do
B1
without
multiplied by R0.
This is why we showed you.
Everybody is okay with this? So your parameters are no longer
At least to
linear.
get the feeling of what is going on, and after that you can.
There
do
is
some
multiplication between the parameters between each other. It's not bilinear.
Everybody is okay with this?
Can we not call
Yes.
all of that
Yes.
This is exactly what we are going to do.
Sometimes give
So what we are going to do, and we are going to
model.
integrate
If you use another
B minus
another
with R
methodology,
and B minus with S.
less complex.
MATLAB can give you 3
But
ways.
remember,
to do
our
the-
objective is to find
the-
R
the
and
continuous
and
B.
S, not B minus
Either
times R and
you
B
use
minus
power
times
matching or use
Objective
Gaussian
is to find
approximation,
R
which
and
is
S.
this one, the exponential.
So how we are going to deal with the
Or you can use
finding
unit.
B, R and S?
So these are methods that you can use based on the complexity of the system that you have. So still MATLAB can be very useful.
All right.
Because there is a system that
So new process equation. This is the new process equation here. that
when we
are
have a square root, we say that the system has
identified.
bifurcation point.
And in any
Complex
new
domain, there are many
equations, for
trajectory
example,
crossing
if I
each other.
write a system like
So
this
there is
here,
not only one single trajectory like this one.
Q squared
At that time,
plus
you need to be-
B1 Q plus B0 multiplied by maybe A1.
طيب, two things that I would like to bring to your attention. This discretization
just an
depends
example.
on
Multiplied by Y of t
the sample period.
is equal, for
You
example,
observe
another
here the time
equation
constant
from
of the
the
system
side
is one.
multiplied by U.
And the
Let's
sampling
say
period that has been
B0
selected
Q
is
plus B1 multiplied by U.
This is half of time constant. During the time constant, you are
Look
going
into
to
this equation like this, I will not be able to work with it immediately as it is. So I need to manipulate.
If you assume that the system will go to 95%,
so the way to manipulate it differently, we take
three times
this Q squared as a factor.
This
So
is
Q
really
squared
not
multiplied
that
by
much.
1
It
plus
works, but
A1
not that much. Normally you have to target the frequency
plus
that
A0.
will give you enough points.
And then we
But you
take Q
cannot
as a
target the
factor
frequency
here.
that is very, very fast, means h very, very small,
B plus
because at that
B1
time you are going
multiplied
to
by
make your
1
system completely
multiplied by U of T.
busy with
And then I
making
take
the
this Q squared and I will bring it here.
Trying to find
So
out
this
what
will
it
give me
is. So it
this
is
equal
kind
to
of
Q inverse
a compromise.
multiplied by B plus
This point
B0 plus B1 Q
Right.
minus 1.
The second point,
multiplied by
we look to the
So
system
basically
here,
what we did,
and
we
when we
converted
solve
the
for the system, I will
polynomial
show
from a
you
function
later
of Q
in
to a function of
in the slides.
Q inverse.
We have a zero that is finite,
And
but
the
the
Q
zero
inverse,
is
we know that it's shift
negative.
to the right. So we are
right, so
going to
you
write
take here
this.
Q, this one
If
equal
I
to
take
zero.
my system without
Q
this
is
term,
equal
this will
to
give me
minus
Y
this,
of T
this element divided
plus
by
A1
0.165.
Y
So
of
it's a
T
negative.
minus 1
So it's in the,
plus A0.
it's a negative.
This one is Q minus 2.
Sorry,
Y of T minus 2. This has
This
to
is
be
negative,
equal from this side
but it's in discrete.
to Q minus 1. I'm going to
You have
keep
to
it
bear
distinct.
with me.
Multiplied
Negative
by
and discrete means
B0 U of T
you are on the other side of
plus
the half
B1
of
U
the
of T
circle.
minus 1.
It's 0.09002
Which will be equal
divided by
also to B0
0.165. So
T
this
minus
one
1.
is very less compared to this. So
Plus
you know
B1
that it's
U
less
of
than
T.
1. So it's within the circle, but
So
it's
from here I can
it's a
extract
stable
what
zero, but
the value of Y of
negative.
T if I know all the history of
everybody's
Y
okay with this?
and
Yes.
all the history of U. So I would be able to predict what would be the value of Y. So I can say here Y of T, this is my new value. Based
Yeah, which
on
one?
all the previous history up to time T,
Okay,
can be
which one?
written as minus A1
Now according
Y of T
yeah.
minus 1
In our
minus
system now,
A0
we have a certain
Y
time
of
for
T
estimation.
minus 2
We have
But we didn't
plus
do
B0 U of T minus 1
How many outputs do we
plus
have?
B1 U of T minus
Depending on the sampling time of the
minus
estimator of
one.
the
Everybody is okay with this?
So now to simplify our analysis, we are going to say we have the same sampling time. So what will be the
So
question?
look at this one.
This is like ARX or RX model.
because
It's an RX model.
control is every
So,
100
but for us,
samples
this is
per
coming from this equation,
estimation
A
gives me like
times Y.
it's 1 second gives me like 2 estimations.
Different models
So now,
later on you can see.
now I
that.
will get 50 output, 50 values
But
of Y.
my objective of all what I did here is that
100.
just to show you the steps. The
First
steps
value
is
is
to
one, but
take
they are very close to each
the
other.
polynomial as function of Q and convert them to
So
polynomial
you know,
as
for
function
example, in
of
Aramco,
Q.
we have what we call the data compression.
Identify the excess
They have some software they run, but they don't take all the
and
points.
the
So what they
shift.
do, they put the limit, upper limit, and lower limit.
This Q to the power
So
of
if they
five.
get the value here,
We have to publish that.
so unless the next value is out, they will keep the same value.
And
They
then
will
from
not change.
here I'm able to express
So,
this as
so you see here the values like
value
this.
5T as past.
They are all this one.
past history of the value of
They
Y
compress
past
the
history of E.
Do we want to deal with compressing data? No.
So for us, in order not to be
This is why I
confused,
told you.
we are
Let's
going
assume
to
that's
put
same frequency.
anything.
What is your
For example, if I have
So
A
the number of estimates that I'm going
equal
to get
to,
from
uh,
A and B,
square
I can make a
plus
logic. I
A1
will say reset A
plus
and B
B0.
every 10
I'm
seconds.
going to say A star
Then it's
of
not.
as a function
But
of
at
Q
that time, I need to pay
minus
attention
one
because the cursor will not work.
is equal to
It has
1
to be
plus A1 Q minus 1
more
plus
sophisticated.
A0 Q minus 2. So I took everything out as Q as a factor, I generated A star.
Okay, any other question?
Everybody's okay with this?
Yeah.
Any other question?
So we continue then
Right, so
our
according to
development,
our
we say that our
compatibility
estimates
conditions, we
are
said
B
that
minus R and S.
BM has
This
to be the
system
same
is no longer
degree as B,
linear in
and AM has to be the same
parameter,
size
but
as.
it's non-linear in parameter. We would like to find the control
Right.
law. This is our
The requirement for to find the value of AM is that zeta is equal to 0.7.
And then we are going to look to special cases, minimum phase system and non-minimum phase system.
And omega
Because they are
n
the
is equal
simplest one to overcome.
maybe it's
The difficult ones, we'll give them as homework as well. All right, so the minimum phase system, we are going to talk about full cancellation. Full cancellation means everything I will put in B plus, right? But I need to put it as a monic polynomial. So the only thing that will remain in B minus is the constant, is B0. Remember this, yeah? We did this together.
1.
So what we have either direct solution of the differential equation or
So from
modified,
here I can compute
filtering. So I'm going
S
to show
squared
you.
plus 2 zeta omega n. S
So if we go directly with the Prefontaine equation, this is the Prefontaine
I
equation.
can
As
assume
you
this
times
is my
BM
BM
y of t is equal to b minus
I
r
convert it to
u
this
t plus s times y of t.
and I will give
But I
the
cannot
value
use
of
it
the
then
n
that
that
is
is
this. So I'm going to
the value of
a
A
star
and
later on when you see this.
Everybody is
First of
okay?
all, we start by replacing b minus by b zero.
Yeah, when you give us this,
Right, and then we include
our
B0 in
now
R.
you're going to
And
estimate
b zero,
based on
so it
of
will
this,
not be the
the response of this.
This is our reference model.
And our objective is to find this RT.
We don't have to go to continuous. We can use e to the power s capital T now that we are able.
Then we define the
S1.
excess pole.
There are 2 poles.
which
S1
is
2 is
given
equal
by
to minus zeta omega n.
We check the
plus or minus
compatibility
j
condition.
omega n square root of 1 minus
And
zeta
then we
squared.
convert everything.
Zeta is less than 1, so it has to be
Find the
like that.
B0.
And then I will use e to the power s
AM
and t.
one.
This
This
is
is
e times s.
gain is to the state.
And this will give me z1. The 2 poles in this case. I can program it this way.
I will come back to this later. So
Now
this is
Bn
exactly the same way we did it before. Then I convert, as I told you here. the
has to be
system
the same
as
degree as
RT
B.
star and AM star. So this is.
So the simplest thing I can generate
And this
is that
is the
Bm
transpose multiplied
is equal
by
to a
B0
constant.
multiplied by theta, or theta are my parameters.
multiplied by q.
So for example, here
I don't have to have another
my
constant.
theta would be A1,
Useless to
A0,
have a
B0,
constant. So I can
B1.
come here and say
And the
my
phi
my Bm is equal to a constant
minus 1 and
multiplied by q. And now
simple.
I can select the value of this constant.
So this is the Diophantine equation. So basically you take all these equations
So
that
how
you
to
have there
select the
and
value
then
of
you
this
reconvert them to q minus 1 and then you extract your value
This constant multiplied by q.
with the
Alpha
respect
times
to
q.
the update that
How
you
I'm going
have.
to select it? Am I clear in
But another way to do it is to look to A0
So what would be the value of
minus 1
this?
and A times AM as a filter.
What would be the straightforward way to find this constant?
We take
Constant times q.
we divide by 1 over A0 minus AM.
Okay.
We will have y of t
So I can
divided by A0 AM.
That's it,
Divide y
is a
of t
constant.
by
It's the relation for
A0
me
AM.
for a
I will
constant.
call these two signals the filter is u and the filter is y. And
So
then
the
I will
question is
have
how
y
to
of
find
t
this
as
alpha.
function directly of
So we
the
can put
control
alpha
times
times
the
q plus
frequency.
alpha 0.
This is a cleaner way
Because
to do it.
here, the only condition we have is that degree of
The reason
B
why
is
it's
the same
cleaner
as
because the
degree
parameter
of
of
B.
A0 AM,
Degree
you
of
know
B is
them
coming
all.
from the system. My assumption is the system has a degree of
Also, if you do all these
1. So
calculations
I'm
here,
going to use
you
BM
can find
degree of
out
1.
if you start with A0
Now, the
AM
simplest
times
way
1,
is to
you
use
will end up in the right hand
BM
side with the parameter
B.
that we know. and
BM is
after
equal to
that,
alpha times q.
you don't.
How I'm going to select alpha?
Why we don't add the constant?
Filtering action.
General first order
Taking view.
system. I mean alpha q
As
plus
passing
General
this
makes it more
this is a
complicated.
polynomial, so it's a filter. I'm taking y and doing the same thing.
0.09 divide 0.1
See?
close to this number. And opposite.
0.09, 0.1 divided by 0.09.
Yeah, because
If you compute 0.1 divided by 0.09.
So my question for you is the following right now. If I use this and I put it in the least square method, what I'm going to get?
So it's not this.
B0 multiplied
we calculate
B0
from
multiplied,
omega
I'm
n.
going to get RK
from the
and ST. right? So how I'm going to get B0? Or R and S.
So
So we need to calculate this alpha based on the error 1 over the DC gain.
this is your reference one. So what steady state error you want to see in your reference model?
0.
0. So alpha will compute it from the steady state required.
Everybody understand my question?
Yeah.
The question is clear? So we have included B0 in RK, in R, صح?
What will be the value in continuous if I want to
And
compute
we
the
have
steady
put
state
B0
requirement?
in
What should I
S and
do?
we call it ST.
Omega n.
One of them is supposed to be
Without
money. So,
the
what will be the B0?
The higher.
So the value of R is supposed to be monic. So when you do the identification, you are going to assume, of course, R is monic, but R is not monic.
How
So
do
you
you
identify are kept in the step, and the highest coefficient,
Goes to
or the coefficient is the highest
No, S to
degree
0.
in
S goes to 0.
This is your
Usually
degree.
MATLAB just put
So
a step.
basically you need to get one.
as equal.
If you get something other than one, then B0 is that value.
Ah, you put the test يعني.
Z equal to 1. Goes to 1.
Z equal to 1. Anybody knows why Z equal to 1? Or in this case, Z is represented by?
Z.
The gain of the discrete system is 1.
Because e to the power
Ahsan.
0.
Because e to the power 0 times h makes Z equal to 1. So if I want to compute in discrete, what should be the gain of the steady state?
How are you
The gain of the system in steady state? I need to replace Z by 1. Yes. So if I go and replace the system by Z by 1, here Q represents Z.
should be the same B0.
But in the identification, you can.
Everybody's okay with this?
You can find something
Q
different.
represents Z, so I have to replace Q
Can
by
you find something different?
1. If I replace Q by 1, I will have
Well, I'm asking you the
1
question.
minus
Can you
1.2305
find something different?
plus 0.4966. What should be the numerator?
So do you carefully
The same. To have again the ratio 1, so steady state equal to 0. So this is how to compute alpha. So we compute alpha by making sure that Bm over Am has a steady state error equal to 0.
Who says that we
Why we want steady state error equal to 0? Because in our control we are making UC multiplied by Bm over Am, and we want to get Ym, the exact value of Ym, not 2 times Ym, 2 times Ym. So steady state error equal to 0 in terms of value. What we want in terms of desire.
So
Everybody's okay with this?
Anybody would like to take?
So this number
I
0.1761
don't care about
is
What would be the
computed
exact value?
to find the ratio between Bm over Am giving you 1.
What do you mean?
Agree? So we found it ourselves. We said how to find alpha. Alpha we go to steady state. This is the
For the example that we took last time, 1. Yes.
Steady state error, we would like to have it equal to 0. In order to make it equal to 0, in continuous S equal to 0,
This is exactly
in discrete S equal to 0 means if
If
Q
B0
equal
are
to
not
1,
the same,
I replace by
then
Q
it's
equal to 1 and I should find the ratio equal to
They are
1.
going to change with the same amount.
So the ratio equal to 1 will give me steady state error equal to 0. From here I have done my Bm over Am, I'm
In
done
other
with it.
words, we don't.
Everybody is okay?
Doesn't make sense? No?
Next step now becomes we have S equal to S0 times Q. B
Plus S1.
because B
And
we
we
said
don't know S0 and we don't know
has to be
S.
decomposed.
The
The
0
minus
minus
N.
S is Q equal to minus S1 over S0.
So I take 0.1065 as a factor.
So if I multiply by
And I
B0,
take
the 0 will not.
whatever is left, and
change.
I analyze if the 0 is in the.
So if I go here and I
Isn't
say,
that
for
one?
example,
Not
I say that R. is
But already I know that
basically
0.1 is part of B minus.
Just B0.
Right, because B
R
plus
equal to
is
1.8. In one of the examples.
1.
1.8. So I'm going here and
So
say
here we go.
S0, this is S0 here.
Our pole, if we try to compute
S0 is equal to S0.
minus 0.09, we will find it around minus 0.8.
S1
It's in here.
divided S1.
It's a stable
S1.
within the circle of 1. However, it's equal to minus.
So the value of the 0 and this one will absorb the value of
Now,
the
if
0.
it is equal to
Try to
zero,
compute the
zero
minus
back
0.8,
again, you will find it
we said
exactly. Z is equal to e to the power s capital
the
T,
0 introduced by S.
and I have z equal
Now it
to
makes sense?
minus 0.8 e to the power s capital T.
So this is exactly what the algorithm will tell you to do. So
Now, when you
basically
look
this
to
is
this-
what we have. We start with
Normally, if we were working on
specification
real
of AM
systems,
and BM,
the exponential is always.
the value of degree of P0. All the analysis that we did before stays exactly.
So
the
in
same.
order to match the two, we are going to say this system can be done as 0.8
The model structure of the
by
plant is fixed.
e to the power
Doesn't change.
j multiplied by.
Everybody understand that? So we assume the plant.
We
We
write
don't know
it
the
in phase
plant,
mode.
but you are assuming
Phase
the
mode, this is the
model
amplitude of the
fixed.
signal.
You have all the design.
And e to the j times 5, it's minus 1.
So
And
based
the
on
fact
that, we identify what should be the value
Plus
of
G
DG.
times
We
pi
write
or
our system as part of
minus
the
G filtered
signal.
Everybody's okay with
What
this?
did you ask?
So I have two possibilities. Either it is a
From
plus
here we are
j
going
times
to
pi,
uh,
or minus g times pi, because the cosine of pi or the cosine of minus pi is always minus 1. It's the same
And from
point.
the value of rt, we'll take the coefficient
Everybody's
of the
okay?
highest. For example, we take it as b minus. We
Repeat
put
again.
this. We identify r.
So we are looking now to b.
This is our
Again,
The
this is
value
very
of p, we are
important.
going to find it based on
We look to b.
A0, our
We
selected
have to
node,
decide about
multiplied
b.
by am1, which is the
Does
value
b
that we
has
have.
poles? We said in our analysis
And like this, we are
that
going to
b
have.
can be decomposed
Well,
with b plus and b minus. And we said in b minus we put all the bit of b, the constant and the zeros that
Everybody is
either
okay?
damped or they are in the right hand.
Now I'm going to explain for you just the filter.
Everybody is okay with this? So I computed the zero, I found it minus 0.8.
I'd like to take an example for
It's around minus 0.8. So it's minus 0.8, this is Z. I would like to see what is the pole in continuous, because I would like to understand what is the dynamic. Is the dynamic something that I like? or
Our
something that I
system,
don't?
we started with.
If I
is,
put minus 0.8 equal to e to the power s capital T,
B over
the matching between the two, if I was
times u
really
is
working
equal to
on
y,
real
and
system,
we
not
select
compressed
this as B0
I cannot put e to the power s
plus
equal to
B1
something.
divided by s squared.
So what I will do in order to make sure that I am compatible in terms of writing, I will write this as no complex numbers can be written as a plus b times j, or can be written as amplitude, which is square root of a squared plus b squared, times e to the power g times theta, the fixed.
value of
So here, since there is no sign, it's a real term, then it's only cosine. The cosine can be pi, and the cosine of pi is minus 1, or it could be minus pi, and the cosine of minus pi is also
So this is our reference point
minus pi.
that we have selected.
So I can say here
In terms
this
of
number can be written either as
degree of b
0.8 times e
is
to
equal
the
to degree of b.
j times pi, or 0.8 e to the power minus j.
Degree
Now it
of
makes sense?
a is
I
equal to
understand
degree
this
of
part,
a.
but just a transition in
This
the
is
zero
the
point
This
eight.
is another
We
difference.
put it because of.
Then we look to the, how did you find
The value of
0.8?
b, which is equal to b0 times q plus b1, and then we computed the 0.
Exactly.
Over 209.
And
So
so
basically
we
what
decided that
we
the
took
0
this
can
number,
be completely absorbed
divided by
by
this number.
b plus. So
So
it's
q is equal to minus this number divided
So we
by
said b
this
plus
number.
that b equals to q plus b1 over b0, and then b minus is equal to b0.
Now I need to find what? S.
What we did with the
Because
previous.
S is going to explain to me what is going on in terms of dynamics. We are very
Now,
familiar
according
with
to,
continuous, but
my
my
system
system
here, I
not
need to
work that
generate.
much. So we would like to understand what is happening when the zero is.
So u filter and y filter this.
So if we take the log from both sides.
Multiplied by am multiplied by u. And then this is the same thing. I'm going to put star here because I'm.
What I will get?
Q
S capital Q is equal to then
for the star
0.8 plus
multiplied
Or
by
G bar.
G.
the value of a0.
Which means that your S
We have the degree of
is equal
A0
to 0. Ln of
is equal
0.8
to degree of a
divided by
minus degree
capital
of b
T
plus
plus J
minus
pi
1,
over.
and we found last time it's equal to 0, so a0 is a constant. For our case, a0 is equal to
We agree with this?
1.
You are following what I'm doing here?
So we are going
Have no idea
to
what
apply
I'm doing.
the next B over the
Ramadan?
previous one. B1 over B0, right?
Yeah, basically you are trying to solve 0.1.
I'm trying to solve the same example that
0.65
we did before, but
0.65
using
times
the
Q
direct method.
plus 0.09.
Zero.
Up to now,
0.2
everybody has
equal to
questions.
0.
Maybe I did some mistakes. This is why you have questions and you are confused.
So and this will give you the value of
Anything
Q.
that
This is the Q that I'm trying to find here. This will give you Q equal to minus
Q
0.09
square, right?
Q squared.
divided by 0.09.
Yeah.
Yeah, exactly. Thank you. But everybody understood this? So basically, if you look at it in the complex plane now,
Yes.
you will do this maybe one time, and after that you will be okay, huh? But at least you know from where it's coming.
UF and what are they?
When you do this
Yeah,
in
the
the
filtered
complex
version
plane,
of
what
U.
you will see is that
So this is the
we
filtered
have
view.
the real part equal to ln of 0.8 divided by capital T.
this
The
is
imaginary
the-
part is pi over capital T. And then the pole is
So basically they are coming from my,
Which means
these are these two, UF and YF.
stable imaginary. What does it mean, stable imaginary?
It has
It has oscillations.
oscillations.
It will create oscillations. Right?
So we took
Now
this,
we said B minus will have to contain all the bad zeros. And the bad zeros are either under
took
that
this
zeros
A0 times AF,
or zeros that are completely
and
unstable.
we divide it all over the left.
For this system, it contains a zero, which is stable zero, but the zero will create oscillations.
I took this
And here is your
A0
judgment. You can decide that this is acceptable. You can decide that this is not.
So when I divide, I will have U of t divided by.
So the first time we are going to do it now, we are going to assume it is
acceptable.
acceptable.
You fit
And
it.
see what will happen. Everybody is okay with this?
By the way, this notion of
This is
split
zero, yes.
signals, we
This
will
is the
see.
value- this
later
is
on.
where you
We are
zero.
going to move
Okay.
to mod reference.
But
adaptive control.
you know, in continuous, you cannot have
work with
a complex number,
the fitted signals.
only one.
Yes.
Up to now, why we said it's also the same as minus j times pi over
Yes,
capital T, it will generate exactly the same zero. Right? It has
Alright, so we have
zeros here. Yes.
the differentine equation, we have A times L prime
Convert the cross function.
plus B minus multiplied by F.
Right now we started from continuous. We converted to discrete.
So
We
if I
found a zero.
multiply by
We
Y of
got the
t
system.
from
Remind-
both sides, I will
maybe this
have
is a
L
bit-
prime multiplied by.
Why don't we just
B
do this
minus.
analysis before the
This is
start
our
of the-
This is excellent question. Why we don't do the question before we convert to discrete and do the analysis?
Repeat the same calculation again.
Right? What will be the answer?
Because we are going to work after in this case.
What will be the answer?
So we have B minus.
Your friend is saying why we did not do this analysis. Right now what we did, we took continuous,
A0, A
converted to discrete, then we looked to the zero in discrete. I converted back to continuous so you understand what's the problem with the dynamics. And now we continue the design. So it's going to continue the design. But your friend is saying
Plus
why we went back and forth,
multiplied by
discrete, then back from discrete to continuous.
So in this case, B minus is equal to.
We know the system identification is discrete, we have to use discrete system. What else?
What is the way it's easy to understand what happened, because why
And if I take
just we
this
have a circle.
and
that
that is
is
to the
it's
right
more
hand side, I'm
confused.
going to write Y.
Because
with
any change of value
R
is
in
big
times
tension.
Y flipped
The question, the real answer is, the
multiplied
continuous
by
there was no zero.
Y. So the R
There was no
here
zero.
is equal to
The
B
zero has been created by your discretization and your sampling theory. Everybody understood that?
multiplied by
That's a
R
very
prime.
important point.
And in
So
our
you are
case, our value
expecting
of
your
L prime is
discretization to
equal
create dynamics for you.
1.
And these dynamics, this is one of them, which is the zero. So this is why we went discrete, and in discrete we noticed there is a zero. We computed the zero, we found it's negative. We said let's go back and then see what the meaning is. But as I told you, do this only once. What you will do next is that from now on you understand that any zero in the left hand side
And then we have
negative will create.
equal to S0 times T0 times.
You don't have to make this calculation again.
2 minus 1. because
What will be the value of the oscillations?
negative, so this one SQ0 minus E0 multiplied by.
You look to these curves. This circle. You see these half circles like this?
Yes.
These are different zeta. Zeta is the damping. So if you look to minus 0.8, minus 0.8 is before zeta equal to 0, which is minus 1, and zeta equal to 0.1.
Under them.
R prime.
It's about omega n.
This is omega n, these ones. Right? This is the value of omega n.
Based on this equation.
Right? These are the circles. These circles are about zeta.
Equation in the slide.
So this is zeta equal to 0, which is the circle of 1.
More
Yeah, you are completely imaginary. Huh? You are completely on the imaginary axis. This the curve for zeta equal to 0.1. This is the curve for zeta equal to 0.2. And here when you are in the positive, zeta is more than 1. 1 and above.
So we have here.
Now when you look to 0 as minus 0.8, you know it's going to create Fourier oscillations. If you want to see how much these oscillations, you look to the zeta that is closer to the
Plus is now.
to the zero. In this case, the zeta that is closer to the zero
equal to 1, so this would be
is the zeta equals to 0.1. This is your zeta. So the system will, or the zero that you are going to create will create for you a damping equal to 0.1. So oscillations
one of the B plus
that are closer to 0.1.
So this is why it becomes only B minus. So and this becomes R.
Makes sense what I'm saying? Or?
And you will see if it's acceptable or not.
I will see if it's acceptable or not.
So why I'm
It will
doing
be
all
the
this
impact
with you
of my
is just to
assumption.
give you
I
the
assuming it's acceptable for me. I would like to go and see what
at the end of the
zero.
day, you have
Yeah.
two filters.
If it's not, what
The first one is how to compute why
If it's not, then we go back to the design table and say we should not ignore it. We should take it as equal to as something that
you
is not,
divided by
is
A0
something that we don't design. This is what design is.
Design basically you divided
Is
by
about, yes.
But if the board
A0 is 1, AM star
imaginary x
equals to 1 plus
or any imaginary x,
Q minus
it's
1 plus
exponential
AM1 Q minus 1.
decrease as exponential. For example, it's
So this is the
we
relationship
can
between
find
you and
exponential.
The exponential is zeta omega n.
if we take this and we multiply it to the
C omega n here.
left hand side, we are going to have U of
E to the power zeta,
plus
which is
AM1
Yeah.
multiplied by
U
pi
of
over
T
t.
minus 1 plus AM0 U of T minus 1 plus AM1 U of T minus 1.
Is it clear now how to read this
Is
thing?
equal to
Clear for you how to read
The U is
the
on the left side.
Some discontinuity between 0 and 1.
There is not discontinuity, but there, if you want, you can have more curves. But if you like,
Everybody is
to
okay
read
with this?
the whole.
Not the more
So from here I can conclude that U filtered at time T
yeah,
is basically equal to minus AM0 U filtered at T minus 1
Zeta equal to zero.
minus
Zeta
AM1
equal to 0.
U
Yes.
filtered at
Because you are in the imaginary axis.
plus
Imaginary axis means that you are
U
complex,
at time.
completely complex.
So I take the value of
pi
pi.
means zero equal to zero.
I take the two previous values of U filtered,
Not that.
and this will allow me to generate the new
Zeta
U
equal to
filtered
1 is
at
this
time
part.
T. And this is the one that I need to
Only
use
the
for the equation that we
half
have.
of the circle on the right side.
For the first step, first two steps.
This
First two steps you have to
Zero.
assume zero.
N. The N.
Zeros or a
And
shift.
3 and 4.
Basically zero or it
Uh,
can
AM.
be what is it? The N. Right?
AM0.
Well, you can harmonics. These are harmonics that you have in the signals because they are multiple of this 5 over. They are harmonics.
To calculate,
And you calculate U fit, I think this is what it is.
Because you filtered, you have to put it
When
here
you look at the system was
to find R tilde and S tilde.
there was no zero in the system.
No zeros.
We convert it into the
And then the zero appears.
the zero appears. So this zero
Make
appears
sense?
due to the sampling period or sampling time.
Yes, the sampling.
So this brings me to the
due to the
now
method of discretization that we are using.
exactly how this
Initially we don't know the
So every time we have a filter is basically we write it in the form of
real dynamic.
differential equation.
This is a good point. Your friend is saying this zero, is it real dynamic or is it due to the discretization? This is what you're saying.
Because if I change the sampling time, maybe there will be more zeros.
It's due to the way we discretize the system. The dynamic that you have, if you want to do dynamic matching or for zero matching, we have two poles, one at 0 and one at -1. So if I do the pole 0 matching from continuous to discrete using e to the power st, I will find 1 over z.
Right, so we do exactly the same thing.
Z minus 1 times z minus e to the
So
power
we take
s, minus 1 times t. E to the power s. But this is one possible value of discretization. Another way to discretize this is
our
we
reference
say that we
model.
have two poles at infinity. Two zeros at infinity. 1 over s squared is also 0 at infinity.
0.5
S equal to infinity, so I would like to replace this simulating up to 100, and we are generating the consequent as a square root. Another thing that we did here, we come and we add the q minus 1. There are many techniques, and you have seen this.
So we take our system, which is b.
There are three ways to do this. Either you keep it as a constant, or you add q, or you add q minus 1, and all of them are valid.
Extract the discrete system.
The way we use
And
discretization in MATLAB give us the zero.
Which is d0.
So in the discrete, the zero is a dynamic that is there.
But I can
In
see
discrete,
the size
zero, the
of the vector
zero
in
is a
MATLAB.
dynamic,
Both,
is a valid
and
dynamic
the size of the vector, what's
due to the discretization.
I extracted what is the
In
exact
continuous, we made
terms of
it.
parameters.
So
And then
the-
I define here my BM
In
over
this
here.
picture,
So I
it
took
may have
the n equal to
or
one,
in-
zero,
we are seeing the zero.
create
But
a
in the
continuous system,
we are not seeing.
discretize the
We will not
continuous
see.
system
There
based
is
on
no
the
zero.
same
But
set
there
of
is zero in
theory.
this.
And
There's
then
no zero in the system,
I
it's coming from the
took
discretization.
whatever
From
must
zero.
give me, I ignore the numerator.
When you
And that will
hold
give me a numerator.
The
Will
zero,
you-
zero order hold,
Yeah,
yeah,
zero.
zero, this is zero order hold, it adds zero minus 1.
Only the value of the sum of the
Can we say
numerator,
if
which
we
is
make
a
our
of
second
a
time
of 1.
close to zero, maybe the oscillation gets less.
So from here I extract what should
try
be
to
BM,
duty.
0, BM1, 0, BM0 should be 0.
Yeah,
Only BM1.
yeah, you need, sometimes it's
Identify the number of addresses equal to 4. Lambda, we are putting it to
so big compared to time constant.
99.
This is your selection.
Equal to 1.
Some, before it used to be dependent on the hardware, still now
I need
dependent on the
initial
hardware.
values, as your friend pointed out, because there are
So if
some
you would
shifts
like
in
to
time. So
buy
I
something
need to
cheap,
have,
you would like to have a
the
frequency
value of
that is not
A0,
that
I
very
need to have the value of
high.
theta,
So
so
there's
0,
something
which is
frequency
0
you can
multiplied by
have.
A1 is constant in this case. I take the value of the parameter of B and S, random, and then I
Pause the, pause, yeah, there is the difference in the oscillation between pause and
then we
oscillation.
take initial value of Y and Y fixed.
Dynamic would be, impact would be different. It's like you have
I can
S squared
generate
plus 2 zeta
And
n
then
omega
one
n
initial
plus
value of U and
omega
Y
squared
and then
denominator.
based on
Is it the same as
this
having
regression, but this is basically assuming that T minus 2 is 0.
I showed you last time, adding 1 0, what will happen?
And then the loop here
I gave you 1 over S squared plus 2 zeta omega n S plus omega n squared, and we told you if I use zeta equal to 0.7, then the overshoot will be 5%. Then I came, I add a 0 in the numerator, 0, stable 0.
From here I can
And the
filter
zeta of
based on
0.7 will give me not an overshoot of 5%, but an overshoot of 20.
So filter, which is just a
You can,
recursion.
you can
Then
do
from
this
there I
factor
get
zeros.
my Y estimate based on
It's available
R0
in the
multiplied by
book of Dorf that I put in the
R10.
Or if you go to chapter number 4, you will see the effect of the zeros.
I use the error, which is between my estimate and my.
Type. Another question?
This is my error.
So all these are valid
My
questions,
regression
because
factor.
when you are going to design, you need to think about what
value
is
T,
going on.
this is your method. I update my
But
T
this
Z.
calculation that I did with you
Value
and
theta.
for P of pi
And
over
once I have the
T,
new
blah, blah,
value
blah,
of theta, I
it's
need
just to
now
make sure
come
that
back
you
to
understand
from
what
the
this
beginning of the loop. From
figure represents. Right?
So this is from my next.
So this figure represents, you see omega n equal to pi over T? We have pi over T. Everybody understood the code? This is your omega n.
So the code.
So
representing
any
the
zero
filter, there are many ways
is
to
on
do it
the
in MATLAB, but we
on
want
this
one that can
axis.
do it.
Even if
point
it's
by
single,
point.
one
So
zero.
there is,
In
MATLAB
continuous, it will
function
generate
that
two
allows you to
zeros,
create
one
and
conjugate,
multiply.
two conjugate, because you cannot have one only complex.
We just use
And
the
then it will have omega n frequency.
So these are the
pi
values of
over
beats.
capital
that
T.
have been
The zeta
presented
for
in
this
the
particular zero
B0
depends on
and
which value of
These are the
curves
values
you are
of
closer
the,
to. Right? Here we are closer
zero
to
and this
0.1,
one.
so we are almost 0.1.
well defined. Don't look
But
at
it's
the
between
eyes.
0.1 and 0, the real value. So it could be 0.09.
So we are not identifying.
What I said here makes sense?
The,
So now we are going to say, let's assume that this is
exactly the same
acceptable.
as we had before with the
We agree with this?
with the ring.
So if we assume that this is acceptable,
Now
this
if
is
you
our
look
first
with the
assumption.
performance in terms of time. This is the performance in terms of time. So the initial values going up to the sky because of the initial values. But after that we have perfect.
If we assume that this is acceptable,
and
then
then
we'll
this
be
is
able
what
to
I
write
did
V
not compute any value
as
of
equal to 0.106
no.
multiplied by Q
Why would we choose
plus A0 or whatever we can call it here.
choice of the
0.8, huh?
because we're not taking any zeros, yeah. B
And then when I decompose B,
So we're limiting
B
our-
plus
So what will happen
times
if
B minus, I can say that B plus would be equal to Q plus 0.8 because
Don't mean decrease. But what will happen in all our algorithms?
I said that it's zero, I said it's okay. And then B minus would be equal
We will
to.
not be able to identify B zero there.
So let me go back to what I did and B did, and you tell me
We
what
agree
will
on this?
happen. I would like you to think about it.
Suppose that I
Everybody?
don't cancel any zeros. I put all of them in
B minus.
B minus. So I have R K be equal to B minus multiplied by R. طبعا all of them star. We are talking about Q to the power minus something of this order. And S still is equal to B minus multiplied by
I don't remember what we did yesterday. I think that,
So what will happen
we
with
did
my
some
all my
examples.
calculations?
Now B plus, B minus is not a constant anymore. It is
So B plus, we said it has to be a monic polynomial. Monic polynomial means the highest degree is one.
I don't have problem with this. I mean, like how we write it, or like that.
this is one way.
Is it 1 plus 0.1, Q minus 1 or Q plus 0.8? At this level, Q plus 0.8 is fine.
And S.
Okay, but I have no idea what B minus is.
Yeah, the identification.
We don't know what B minus is. So B minus is something unknown. We said that we are not, we don't want to identify B and A. At least that.
Any other questions?
I'm going to change the data. but
Am I going fast?
To find
Clear?
B and A. So
Not
how
fast?
I'm going to deal with this. Well, this one is easy. B0 is the coefficient.
Doable.
The highest power. It's easy to explain.
Compatibility conditions.
But
We
what-
have AM, we selected the second order system. So degree of AM and degree of ADR equal. Degree of BM and degree of B.
First of all, the good news is that
One,
we
one.
can apply
So
the same
equal.
way.
So these compatibility conditions are
That's
satisfied.
the good news.
Now we need to
We are not
know
confused.
what's the degree of A0.
And we are not limited.
So degree of A0
Now I'm
based on
asking
my
you
analysis,
if you are the one presented with this problem.
degree
This one here.
of A0
Well,
is
B
equal
minus
to,
is a
according to
polynomial
this formula. Degree of
still with B minus times R and then degree.
Degree of A, what's degree of A?
Or how we will deal with this?
2. Degree of A is 2.
What will change?
Minus
So B plus.
B plus 1.
degree of B plus. Degree of B plus is 1.
1.
Minus
1.
1, which means
0.
0. So we don't need A0.
Anybody would like to take a shot?
A0 is a constant, but it's a monic polynomial. So since it's a, so we don't need it. It's 1. So A0 is 1. Yes?
A0 was.
So what we do, we continue the procedure exactly the same.
Yes, they
We
observe.
don't change anything.
So here A0 is
What about the degree?
The degree will be higher.
How do we separate it?
How do we
Yeah,
separate
yeah,
them? This
yeah.
is the question. We separate
Then
them
it
by
says
the
you need to find R prime and yes. Degree of S, we are going to take it to maximum. So degree of S
compute the zeros of our
is equal to n minus 1.
of
So which will be equal to
1.
1.
We'll
So
find
this
the same
implies
zeros.
that S
the same
can
zeros
be written
as
as S0 times Q plus
Theoretically, they can have the
or
same,
vice versa.
depending on what we are going to write.
the same zero, but it would not be.
Everybody agrees with this?
R,
So you see now why
have
we
one,
understand that we need to
One common zero, except for.
range from 0 up to n minus 1 because if we take from 0 up to n minus 1
Because we will take it off, it
we
will
are
not be the
in this
controller.
case of course it's 0, it's 1 or it's 2 but
Doesn't
it's
matter.
0 or 1 but we'll have many possibilities if n is equal to 10 we
Yeah.
fix ourselves to 1 value
As long
And
as
then
the
this one we
different
have
equation is,
two parameters that we need to find
The dynamic that I want is coming. I'm having it, sir.
right two parameters of s S0
Right.
and S1
You have
we said also
you
that
have
degree
A times
of
R plus B
R
times S is equal to A0.
is bigger or equal to n minus 1
Always very valid.
So since
Then
I
we are
selected
getting
degree of
here.
s equal to n minus 1, I can select also
The
degree of
question
r
is how
equal to
what's
n
the
minus
quality
1,
of your
which implies
controller, the signal. Yeah. So I need to take
R?
from the controller. I need to take out the value of
is
R
equal
from the
to
controller all the zeros that I will judge underdamped. And for me, the underdamped will be
is equal to 1,
the common zeros between R and
which implies, right? So
Are
this
we
is the
both
degree
together
of
in
R
this?
that you are looking at. So degree of R is equal to
unification. No.
So we said that R are going to
if I look at it in
decompose
the absolute
R,
value, there
R
is no
prime
common zero.
multiplied by.
So I need to put a margin.
Since the degree of B plus,
If they are less than this, then
It's
they are
one.
the same.
so R
Everybody
prime
is
will
okay
be.
with this? So
No,
this is
one,
the
one,
only-
one.
The degree is
You can just say it as one.
What?
the degree is
For example, the.
So can you repeat why R prime is equal to 1?
The zeros of R here, the S here.
Why is that R prime equal to 1?
Zero plus is one.
Degree of B plus is 1.
D minus degree of D minus for example is zero or two.
Degree of R prime is 0.
Yeah.
So the real answer, for some cases, we are going to be stuck.
Constant.
Because we are going
It can
to
be
find
constant, but we selected one. Why it cannot be 2, 3 monic polynomial?
So the way to go around it is that we mix the algorithm.
We are okay with this?
Mix the algorithm means that I will create a hybrid algorithm. The algorithm is not fully direct and it's not
We are okay
fully
with this?
indirect. So I will use what we saw last time to estimate B and A, but I will not do any calculation in R and S. I will use the value that I'm going to get in B and A.
Yeah, it's bigger or equal.
Will compute the value of R
So
and
it's
S.
selected equal.
Everybody understood that? خلاص أنا كملت اللكشر. All the slides they are talking about what we said right now. Okay. The more we selected the bigger number, the more it will be.
So basically this is what it
minimum
is.
degree design.
Now comes the work. I'm going to assume we have B over A, and we know the value of A from the previous slide. I'm going to assume A as equal to 2
So all these
squared
conditions have to be
plus
verified. I
A1
have
cube
to be consistent in my work all
plus
the time.
A0.
When I'm getting all these values. The filtering is very important because it allows
What
you
is
to
A1?
look for
What's
some
A0?
kind of anomalies in the data.
I don't think that we have already.
This is the example that I have
So-
seen before.
A1 will be equal to minus 1.6,
So the algorithm
0.65.
is
and A0 is equal to 0.6.6.
come back to this data.
The reason why I call them A1 and A0 because I don't want to repeat again every time 1.6.
The value is repeating the zero. This is the case of non-
And I'm going to come to this one and then say AM will be written as U squared
common factors
plus
between R and
AM1
S are considered to be the B minus.
times Q plus AM0.
So this is
Right? Whatever, you can call them semi-1, semi-0, Ali1, Ali0, nobody
the other
cares.
way to do it is to mix
And
the
then what's the value of
So we
AM1?
use the
Minus
algorithms
1.32.
to find
What's the value of
B?
AM0?
By now B we can compute B minus. So we know B minus from the beginning.
Now based on this, I am going to go to my equation.
That we have. Now, in our algorithms, we are computing the value of R and S, and then T is given directly by our calculations. We are also able to.
The algorithm say A times L prime plus B minus
So
times
we
S
no longer value
is equal to A0.
Just
A.
add T
So I'm
and
going to
R.
write here A, which is S squared plus A1Q plus A0 multiplied by L prime, and you said L prime is 1.
And rather than having the equation y as function of u of t and y,
Thank
we will identify based on the error.
So why there is nothing here?
And t will be here.
Because what? L prime is equal to 1.
So t becomes part
This
of
is
the
the L prime.
identification algorithm.
Right? So here we
We
have
new
1
parameters that we need to
multiplied
identify.
by 1 plus
Does it make
S
sense what I
S0Q plus S1 or S1Q plus
So,
S0 if you want to follow the same
This is exactly what we
nomenclature.
cover and we'll
So
finish
be
this topic of
consistent
because of
Nobody cares.
polynomial controllers or RST controllers.
Multiplied by V minus, and V minus is equal to
This
0.1.
So you have two ways to do it.
This is equal
You take
to
your algorithm and you modify it, and you put the new system
AM,
and you try
because
to
A0 is
I believe
1,
you
so
are
Q squared plus AM1Q
you are able to solve
Plus
the
AM.
Programming means that you put your ideas in orders, right? And
You
if
agree
you
with
put
this?
your ideas in orders, any problem with
So
that is easy.
this I'm going to
And this
write
is why I'm
it
asking
equal,
you to program
and I'm
it.
going
I have
to
the program, I
rewrite
have
this
the
equation down here.
But it forces you to
So this
understand
would be
the
Q
steps.
squared
And this will be
plus
beneficial.
A1
So I would like you to
plus
reprogram the
S1
problem
times
with
0.1
the same problem that
065
we did
times
in
Q.
class. Assuming that
Plus
you have B minus cancelled
A0
or B minus not cancelled. Put
plus
it direct
S0
and indirect
multiplied
at the
by
same time. And this will be your assignment
0.1065.
for next lecture.
3.6.
Everybody understood from where I got this equation?
The same problem with
So this equation is coming from
direct and
this equation that we have
Because
in
you
the
have
top
the
here.
results also on the slides, the curves.
Anything
You
not
have to
clear in my writing? Everything is not clear.
What session?
Nothing is clear?
What session?
The guy next week.
Like, what should I do next?
1 week.
Wait.
Not 1 week. And
1 is
4
equal to
days and
1?
5 days and
We're done?
1 week.
This has to be equal to A1.
Okay? Only 1 week.
And this has to
1
be
week,
equal
you
to
change your program, you just add the design parameter to the program that you sent me before. And then you have the same algorithm in the book. by the way.
We have how many parameters to find?
Look into the book.
What are the unknowns?
The algorithm is fine with me, as long as you understand. Sequence.
S0 and S1. These are our unknowns. Okay? So we are going to write
What I will
A1
do you next time is,
plus
I would like to know
S1 times
anything about it.
0.1065
I would like to do adaptive but without it.
is equal to
So I don't want to do identification at all.
and then we have
And we are going to start,
E0 plus
right now we are
E0
working with
multiplied by
input output systems. So we are
0.1065
focusing on
is equal to
Y and U.
which implies
So next
that S1
method
is
that we are
equal
going
to
to see
AM1
will allow us to find
minus
controllers
A1
without
divided
identification
by
output.
0.1065.
And from input output. So still we are looking to single input, single output.
And here it implies that S0
Everybody is okay
is
with
equal
this?
to A and 0.
Later on, we are
minus
going to
E0
ask the question what
divided by
happens if we have
0.1
multi-variable system. And then we move to the
Am I done?
design. Is it clear what I said here? All right. Khalas. Thank you very much. See you inshallah Sunday.
So we are left with T. And T is equal to
A0, B.
T is equal to A0 multiplied by Bm prime. And the value of Bm is equal to Bm prime B minus. Do we know Bm? Yes. So Bm is equal to 0.17 something multiplied by Q. So Bm is given here. It's equal to Bm0 times Q. So I'm going to write it as Bm0 times Q. Now Bm0 times Q is equal to Bm prime, I don't know, B minus is equal to 0.1065. Right? So 0.1065 multiplied by Bm prime. Everybody is okay with this? So I'm able to find Bm prime equal to Bm0 divided by 0.1065 multiplied by Q. You agree with this? From here I can conclude that T will be equal to Bm0 divided by 0.1065 multiplied by Q. This is the value of my We agree with this? Are we done? We have R, S, and T, and we are done with this case. What I did, anything clear first? Yes. Anybody has any comment about what I did? Anything that I went very fast, it's not clear? Yes.
How we select the value of R prime as a 1?
Why?
Why, yes. It was a monic polynomial, but I didn't understand clearly.
Okay. We said that the degree of R is equal to n minus 1, which is equal to 1 because n is equal to 2. And R is equal to R prime multiplied by B plus, which means that the degree of R is equal to the degree of L prime plus the degree of B plus. What's the degree of B plus? 1. So 1 equal to degree of R prime plus 1, which means that the degree of R prime is 0. So it is a constant. Why we selected equal to 1?
Monic.
Monic polynomial.
Does this method ensure stable R? Because we have S over R.
It is stable R. It's going to be stable R.
In general.
It has to be stable R because you are making you have your reference model, and you are not inversing the unstable zeros if you want. Right? So the stable zeros, we are not including them in R. It makes sense? Yes? Yes? I know it's Thursday, the weather outside is really nice.
Yes.
Beautiful. Any question before I go to MATLAB? Then MATLAB is now simple. Right? So I did 2 programs for you in MATLAB. The first one that I'm going to use will be I need to use for you one simple one first, and then after that we'll make it a little bit more complicated. Are you able to see the writing here, the code? Shabazz? Yes? So in the code I put here the sampling period, 0.5, as we said. I took the transfer function, which is 1 over s times s plus 1. Is it clear, the writing? Yeah. And then I converted the system from, in fact, this one is just to write it as a numerator-denominator with different numerator and denominator here. I discretized here, continuously discrete G and H. Then I identified all my parameters. What is B0, what is B1, what is A1, what is A2, right? So B0 and B1, B0 times Q plus B1 on the top. And the bottom you have A1, Q squared plus A1 cubed plus A2. Then I took my specifications, omega n equal to 1, zeta equal to 0.7. I created my transfer function, which is omega n squared over s squared plus 2 zeta omega n plus omega n squared. I converted to discrete. I extracted the numerator and denominator. Then I changed the numerator to make sure that the numerator has a gain equal to 1. The system has a gain equal to 1. If you do this in MATLAB, due to the frequency that I used of h equal to 0.5, you will also have a 0. And the 0 is not Q, it's something else. So I ignored the 0, I replaced with my 0. And my 0 is 0.1762 multiplied by Q. Then after that, I generated extracted the value of Bm and Bm1 and Bm0, which means the numerator coefficient of my reference model, and I extracted the coefficient of my reference model denominator. All right? Then,
Doctor, why you divide with 1?
Sometimes
Bin minor.
they don't give you 1 and
Sometimes the
default is square. They don't give you one.
Oh, yeah.
it gives you something else.
What's parents? Beta,
Beta, just to correct, make sure the gain is equal to 1. Well done, huh? Beta is here. See, it's the inverse of AM1 and A2 divided by B0 plus B1. So make sure that the gains are the same for both systems. Then I compute what should be B plus, what should be B minus. In this one, this is another example. I'm so sorry, but B minus and B plus. I should not use this one. Maybe this one. This one, there is the this is the one. This is the one. Okay. So I selected B plus equal to Q plus B1 over B0, and then B minus equal to B0. They're exactly the same thing that we did here. And then Bm prime, of course, it's equal to Bm divided by the value of B0. Yeah. And then I compute all the thing, and then I put a step here, and I plot whatever is happening with the system. That's it. This is the design. Assuming that I know the value of B and A, they are known for me. So if I run the system here and I see what will be the performance, since I said I know the exact value of B and M, they are known for me. Then we get what you get here is the plus are the reference model, and the circles are the response of your system. So they are one over there.
Yeah,
Because I know the system perfectly. It's a perfect model power system. Very perfect one. You are okay with this? So now I'm going to add the identification and see what will happen. Yes. Right? So I'm going to go back to my code. And need to look to this one. So here, what will happen? I need to add the estimation part. I'm going to estimate the value of A and R in every loop. So what I need to identify how many regressors I have, how many parameters I need to identify. So I need to identify 4 parameters, 2 in the numerator, 2 in the denominator for B and A. Everybody understood why 4? 2 coefficient of the numerator and 2 coefficient in the denominator. So this is 4. I selected lambda equal to 1 means that I'm not forgetting anything. So this is every value of time has exactly the same equal weight. I use it P0 equal to 100. This is.
We don't trust our.
I have a little bit of trust. Not that big, but little bit of trust. Otherwise, I need to take it very big. Then I took an initial value of theta. And the initial value of theta that I took here, you can see it's very far from the real values. -2, -1, 0.01, and 0.01. What I did make sure of, however, is that the denominator is stable, so it gives me zeros. The poles are within the circle. But the numerator, I just put anything. Then I took the initial value for these coefficients, and I started my loop estimation. Of course, here loop estimation, when you look to your difference model, since you have Q squared, then at that time you need to write it as Q to the power -2, etc., and make the time shift in your domain. So the time shift will give you this. It will give you m1 of I minus -2 minus -1, etc. So yi of I minus 1, this is here. Then you have yi of I minus 2 plus ui of -1 and ui of -2. This is just my way of coding. We generate the value of phi. We compute the value of k for the least square method. We know that now. We know how to implement the square method. We compute the error between my estimate and my real value observation, and I update the value of theta. And then once I get the value of theta, I compute that. B plus, I compute B minus, and then I compute what will be the controller values. Then from there, I generate the value of T. I compute the closed loop system. I compute my control, and then I come back to the beginning of the loop. I introduce my control there. So if anybody will ask me what are the steps of your code, I will tell them first step is estimation of A and B, because my method of design requires for me to know A and B. So I cannot start designing without A and B. I start by designing A and B, and then I do exactly this algorithm that
What we did.
exactly the same thing as it. And then I iterate with the same frequency. Once I'm done, then I plot everything. Is it clear what I said? So if we run it here, we are going to see what is going on with the system. These are the estimate of my parameters. Estimate of B. So we have the green one is your exact value. This curve is your estimate with the least square method. This line is the exact value, and the red one is your estimate. So you see there is a transient where your estimate is very far from the exact value. This is for B. And then for A, it's the same thing. I can see that A starts here from the top and goes to the exact value. And the same thing starts here at the bottom and goes to the exact value. And I converge. In all the parameters, I converge at a certain time to the exact value. Up to now is okay?
Yes.
So during this transient of the estimation of my parameters, the A and B that I'm using are not the correct one. They are still in transient. They are still in transient. This is the control signal. Right?
Yeah.
The control signal is like this because I'm using step change as an input. So in fact, maybe I should start with the step before I go to the control, because by itself, the control is very significant for me. This is the output. So I put a stair step. The green one is my reference model. It's very slow to update. This is here. So the blue one is your reference signal. So I put a reference which is the staircase. You are okay with this? The green one is your ideal model. This is your BM over AM. This is how the system behaves. This is your YM. The red one is the output of your system. So you see here, I start with an error between the two. Especially here, you can see the difference between the model and the reference. It's not the perfect model following. Then the more you go, the more there is a correction. Until at a certain time, you will get the perfect model following because you converge in terms of parameter of estimation. All right?
So on the horizontal line, this time is in the seconds, or 0?
Yeah, it's whatever, seconds. Unit of time, seconds. So if you zoom on one of these, so if I zoom on this part, for example, here, you can see the difference between your reference model and the real system. Huh? And this is, you see here, the values are incorrect. Your parameters are not the right values because you are still in transit in the identification. You have an error, but you see the system is trying to correct with S over R. The S over R is trying to bring you close. Yes, but it's not enough. You're still having error. You exceed, you come back, and once you achieve your parameter converge, then you see the error here is almost zero. So you have perfect model following once you converge in terms of parameters. And the signal is beautiful. The output is beautiful. So let's repeat again what we did. We estimated the value of the zero. We found it's equal to minus 0.8. We said that this will introduce oscillations, but we will accept it part of B+. Accepting it part of B+ means that we put it in R, because R is equal to R prime times B+. So R contains the zero. is the oscillation. And R is in your controller. So the output of your control is this. So you understand now why the system is giving these kinds of oscillations? Because of B plus. Because of the value of B plus that you just assumed it's okay.
Can we consider this as chattering?
It's not chattering because the chattering is normally on the state, in the output. This is oscillation in the controller.
But this will affect our actuation.
It affects your actuation. So basically, if you have an airplane, you will see the flappers doing this all the time
Yeah.
in order to keep you stable. So what you see at the output is a very nice signal.
But
Your airplane is really does beautifully well. But in the back, this is in order to keep you on this level. You understand what I'm saying here? So imagine that if there is an unstable pole there, what will happen to the control?
So,
Huh?
stable.
You don't fly this afternoon, huh? Everybody understood? So we call the system here, the control is ringing. Ringing means it's giving me oscillation. And these oscillations are due to the...
You can see it as an aggressive response of the controller.
Huh?
You can see it as an aggressive response of the controller. Or not?
It's not that aggressive, but the controller is trying to compensate for the oscillation created by the zero. Because the controller is trying to do whatever he can.
So it is acceptable.
If it's for you acceptable, it's acceptable. You are the designer. Somebody will come and say it's not acceptable. You are going to break the airplane after 2 or 3 flights. Okay? Somebody will say no. You know, in the airplanes they have a log for every flight. So even if the pilot arrives and safe and everybody is happy and you go home and you are eating your dinner, there is people there. They will go through the log file to see what the pilot did during the flight and how the airplane behaved. So if they see that he did some maneuvers where he exceeded some of the limits that are not tolerated by the company, they will give him blame. Right? Because all the signals are recorded in the system. Somebody will go with a data recorder and download all the data, the flight from the system. But what I did here with you is okay. It's clear. Make sense? All right. This is fun, right? I will stop here for today. What I will do with you, inshallah, next time, we are going to come back to the sixth example and we say, this is not acceptable. I'm going to put the zeros in B minus.
Ramadan, Dr. Muhammad said he has a problem with
What's the problem?
Tuesday.